Okay, my friends, once again, Roger, Mudfossil University, talking today about physics and electron dipole flood theory. All right, dipoles make up everything there is. In other words, a proton is not one big thing like this and a few little quarks inside. It's made up of 1,823 little bar magnets. Simple as that. Very, very simple. And 1,824 would make up a neutron, which means it doesn't want to give any up and it doesn't want to take any on. 1823 is a charged particle, which means it has either an excess or electron, or it either wants to give one up or wants to take one on to become stable. Stability is neutrality. Neutrality is stability. Basically, that's it. Now, they're talking about cracks are appearing in the second law of thermodynamics. Well, it's gaping, gashing holes. Everything they've said is wrong because they can't justify anything with this model of the standard model. There's a big, heavy-duty proton and a couple of little tiny electrons make up these atoms. It's not that way. They're all made of these tiny little particles. There's zones of stability, and what are those zones of stability? They're called atoms. They're called elements. And all they are is bigger and bigger chunks. Hydrogen starts out at about 1,825 or so particles like that in a ball, and then they go up to tens of thousands. And in between each one, there is all these different particles. You take a few off, it's still the same element. You put a few extra on, it's still the same element. They call them isotopes. And they have only certain terms of stability, what they call a half-life. But they want to get down to that one exact spot, which is the zone of stability. So look up isotopes of anything. Look up isotopes of carbons. There's dozens of them. And they're still called carbon, but they're different weights, they're different charges, they're all different because they're just more or less and less of these particles. And it goes both ways. And then right in the middle is the zone of stability. I hope that makes sense. And when they smash these things together, because they're using protons, we're using light. The things I'm going to show you are based on light. We're using this. Right there. All right, they're using these, boom, but they don't realize that they're actually using balls of these and smashing them and getting all these particles. Yeah, they can see all the particles, but all they are is bits and pieces of these. Some of them are big pieces, very radioactive, and they really, really want to get down to zones of stability, so they give off big chunks, and that can hurt you. Other ones are just little isotopes. They're just not exactly stable yet, but they'll get to stability before long. But the real bad ones are the ones that are like that. They're way off. They really want to get down to stability, and they will just go flying off. And when they do, you don't want to be in the way of it. All right, that's radioactivity. So hopefully you can understand what I'm going to show you. But they realize they got all kinds of problems. They can't even explain gravity. They don't even realize that the universe, the ether of the universe is filled with particles. It's ether. You see this? Got another book about ether particle theory. This is another book about my research. These are books about my research. I'm not really involved with the book, but they're about my research. And this was a paper I put out in 2019, and Paul Amatucci's writing the books about them just to show my research. And this was in 2020. They're saying all these kind of problems are coming up. Yes, absolutely. Not a single thing in physics is right because they don't understand the nature of the subatomic particles. I actually show light, the particles of light, the muons and the electron showers, which is fission and fusion. It just needs to be looked at by somebody that is in these, you know, these super colliders, and they won't do it because it really negates everything they've been talking about. These are the particles they want to find, is the smallest particles that exist. You don't have to start with these huge machines. Right now, that's what their whole way of life is these gigantic machines. So they won't look at what I present, and I'm going to show you what I present. And if you can, you know, we need something, we need to advance the understanding of how we can get free energy and fission and fusion. And this right here, I think we can use, and I'll show you how we can split this light. And part of it, the white showers, is nothing more than the electrons. It is 100% electrons. And that's what we need, because that's the only thing that you put in your batteries is the electron part. All right, everything consists of a positive and a negative, the black and the white, and I'll show you those. But we want to get the white, because the white is the one that burns. That's the one that really does the energy, and that's what you turn on your electric stove and everything burns up. You turn on your hair dryer, you turn on your whatever. Resistance, anyway, that's fully understood. When you charge up a battery, it almost doesn't have any excessive weight, because there's one particle, the white particle, has almost no weight at all. The black particle carries all the weight. Fully understood, and was written about years ago, 2013, by Fermilab. And I'll show you their article, and I'll show you their pictures. It's the same pictures we have. Only they did it by seeing a bunch of debris and saying, wow, look at these little bitty things. Well, we use light to start with, so we can see those little bitty things actually propagating and turning into muons, sterile muons, and then into electron showers. From electron neutrinos and muon neutrinos into sterile muons and electron showers. That's the holy grail of energy, is electron showers. It's supposed to be up to trillions of giga electron volts. Extreme amounts of increase in energy, and I can display it. I can show it. See, this is the problem with science. Nobody pays any attention to anything. This was back in 2021. They had scientists generate matter directly from light, phenomena predicted more than 80 years ago. So this has been known about, and it comes and it goes, because nobody listens. And now all of a sudden it's a brand new thing. Okay, so we're going to make matter from light. Well, guess what? They don't understand what light is made of in the first place, and they don't understand what protons are made of, because we know that matter is made of protons and neutrons. Everybody would agree with that. Now, what are protons and neutrons made of? Well, they're made out of quarks and bosons and fermions and hadrons. They got all kinds of names. No, here's what they're made out of. They're made out of individual dipoles. And my calculation is approximately 1,824 of these particles make up a neutron. 1823, which is charged because it's not even, makes up a proton. Now, when they hit and collide these particles, one or two little pieces can come off. That's not a problem. They see that as making matter. It's not making matter. You're just knocking a little piece off of something else. It's as simple as that. All right, let's see what they have to explain here. This is Sabine, and she's going to explain what these charged particles do and how they create matter, they think. And as I said, or will say, it's just pieces of the main particle, which is the photon or the protons or the neutrons. We'll just knock off one or two little pieces. They're called isotopes. They just never take this into account because they don't understand it. I'm serious. The top physicists just don't understand it. All right, I'm not going to get too deep into the article, but these are the particles they see, the smallest particles. That one they call a point-like particle. That one they call a fixed particle. This one never changes. This one gets big and small and has no mass, they say. This one has all the mass and never changes size. And it says in summary, the extended particle, which is the black one, have a fixed size. That ball never changes, and I can show you that's true. They may have a fuzzy edge, which they do. The point-like particles are mathematical abstractions with zero size. They do appear not to have any mass to speak of, and I can prove that too. But the zero-size particles have an extended field, which they do appear to have that. That's true. And it's the effect of the field surrounding them. And that's the thing that gives them the energy, is the field. And I don't know how it creates it without a size or a mass to it, but it does. Okay, this is completely wrong, but let me read it to you. A nucleus is made up of neutrons, protons, and electrons. No, it's not. It's made up of tiny little bar magnets called dipole electron flood. Protons and neutrons themselves are about 1/10 the size of the nucleus as a whole. An electron has near zero mass. I do agree with that, but the electron is the white part only. It actually weighs 500,000 times more than a neutrino. I can't possibly imagine that. 500,000 times more than a neutrino. Well, there's a black neutrino and a white neutrino. We're going to look at this in a second. They can't measure these. It's impossible to make a measurement at this point, so they really have no clue. They're just guessing. But matter is made of little bits and pieces, and smaller and smaller and smaller. But by the time you get down to what it's really made of, it's these. These little bits and pieces are dipoles. And this is light. Light is atomic vapor. The more light you can put on something, it makes it grow, like plants. They grow because they're getting hit with light. The more light you flood them with, the more they grow. Electron flood is matter. Light is matter. It's matter. So light matters. All right, you saw that Don Lincoln had that article about the black particle and the white particle, the fixed and the point particle. And this one goes big and small, and that's it right there. And the other two bits are the black particle, which is the fixed particle. This is what it looks like, and this is what it looks like because it's red. This is in the black and white phase, and you can see it is the two dark particles. Now, what is this? This is a bar magnet. This is a bar magnet. And they polarize towards the Earth. They all polarize towards the Earth. They talk about the spin, up spin and down spin. That's the polarity towards the Earth because they're bar magnets. Now, we're at the smallest bit you can get to in magnetism. You cannot break a bar magnet apart and end up with a plus side and a minus side. It doesn't happen. You end up with two bar magnets forever. Until you get to this point, there's no more bar magnet to go. So you can separate the black from the white. I never thought it was possible, but here it obviously is. This is the particle. And it is the same particle they're talking about. They can see these particles at CERN and Fermilab. They just don't know where they came from because they started out with a big ball of particles. And I'll show you. Well, let me just show you that to make sure you understand. Here's what they see when they smash the particles together. They see all this. And what does this consist of? Well, first of all, there's the photons right there, which I show these photons very, 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 very clearly. Now, in addition, they see the little bits and pieces, these red, these blue, and these green bits. You see the green and the blue and they see all these little particles come flying off of this proton-neutron smash. And this could be one of these that's going to really hurt you. And then the other ones are neutrinos, or they're photons, or they're the little point particles. They're little glowy bits. Like that would be a neutrino. Now, let's go back to this. Hold on. All right, what I'm going to show you, this is virtually impossible to believe, but it is factually true. I worked with Rod Warren for 4 or 5 years, maybe even more. And it started out, and it's still ended with this Samsung Galaxy S3 phone. And this goes back to 2014, and it had some kind of CMOS in here, which is complementary metal oxide silicates, which pick up the light. So we're not interfering with the light at all. We're just letting it come and smack into the selfie side. Rod used the selfie side, and he said that worked better. So it must have more pixelation. But anyway, this is what he was picking up. Now, he used this Bosch construction laser, GLM-15. Now, he had the metric one. I guess this is, I don't know. Anyway, and that's all he did. This is pulse red laser from this Bosch, and he used the selfie side to read all of this illumination. and take pictures of it. And unbelievable. And I mean, he must have spent just staggering amount of time. But what are we seeing here? We're seeing a wave, and I can explain that wave because the particle has a magnetic field surrounding it. All right, every bar magnet has a magnetic field. So that magnetic field's coming through here, and every other particle in the air has magnetic fields because they are all made by the same particles. So this has to push those things out of the way. So they glow a little bit, and this glows a lot. Now, all of a sudden, it starts to accelerate because there's a Venturi here. A Venturi was made with just literally 2 finishing nails, something similar to this. And the laser went right through those 2 finishing nails. And what happened was it created a Venturi, which is a round surface here and a round surface here, so tight together that only the white could get through and the black couldn't get through. And that's what you see right here. This is fission. And you see this glowing. That's the kind of energy that they're looking to try to create, from almost total darkness to just literally a subatomic nuclear explosion. And these are the reverse EMF. You see those little lines? Hold on. Maybe that gives a little better shot at it. Those little lines back there are the reverse concussion. You see those backward looking lines? All right, and these are all light waves. This one here is accelerating forward, so we're seeing it glow because it's concussing, being pulled forward more than it normally would. These are in the air, but you never even see them. You never saw those. It's this exact same field as this, but they're just sort of flowing through the air. Now with that explosion, it's pushing back with such violence that the leading edge of it, just like the leading edge of this, is glowing like a fire. Now, can I show you this separated and this? Yes. And can I show you what they say at CERN about that? Yes. And is it fission and fusion? Yes. And is it electron showers? Yes. And is there an enormous increase in electron shower energy? Yes. All right, let's just take it from right here. This is the CERN particles, the Fermilab particles. They know they're there. They just didn't know where they came from because it's in just a pile of debris. Now, this is our stuff. This is the actual light particles, and the green is exactly the same. All right, so you have this black and white. This is a bar magnet. It polarizes by the Earth, upspin and downspin. The one that's going forward, you see this one here charging up? You see that little white spots in front of it? It's being concussed because it's going forward through all the particles it has to push out of its way, as I showed you before. So it's swelling up, and it's going to get big like this, and then it's going to flip to the back, and that discharged one will flip to the front. And that's what they call a muon wobble. It's really the spin, and it spins this way. So sometimes this is the downspin, and sometimes it's on the top. It's an upspin. That's all that is. And that's light, and of course that's the red. And don't forget, he said it has a glowy edge around this black fixed particle. Absolutely. And the other one has almost no mass, but it burns like hell. And I could show you that the black pushes the white. Watch this. This is the black pushing the white. You see the black right here? All right, this particular Venturi rod had it set so that a little bit of black came through. You see the black coming through right down the center, but it's pushing the white, you see? So the white is concussing and getting big. Normally the white would be the same size as the black, but it's pushing so hard because it's been accelerated. So the white has to really, really push, and it sends out these ripple waves of magnetic push to shove. The black has no magnetism. The black has no magnetism whatsoever. All it is an attractor, a holder, a pusher, a carrier. The black is a carrier. Think of it that way. It carries the white. It pushes the white. And that's exactly what we saw in the electron showers. But this is a magnetic field way out in front. The black will not create a magnetic field. This does. And if you ever hear of a nuclear bomb blast go off, when it first goes off, you hear, and that's all these coming off first. Then the white particle burns the house down, and then the black hits it and knocks it down. All right, my claim is that the atomic bomb is going to go off, and all the white particles which surround all the black are going to come out first, because they want to just get the hell away from each other, because we've forced them to be crushed. Now the black will come out following it. And the first thing they'll do is the house will just smoke up, and the wires, the poles, will just vaporize, and the whole air will become completely saturated with electrons. But it doesn't push anything; it just smokes. I can't explain that effect. I just can't. But this is what happens. Now watch. Here it goes. All right. The first thing is, see, everything glows. Now look, it just burns up. It's just smoking. I stopped it. It's just smoking. See the poles? You see the wires? I'm just going to hit it a couple times and pulse through it. See? Look, everything's just smoking. Just smoke coming up. It didn't push anything. Look at the wires. Just the wires are just vaporizing, because it's being hit by atomic vapor, which is the white particles. See it? Look at that. Now the black will come, boom, you see, I just stopped it again. And it's just, now it's gone. That's the concussion wave, that's the black part. So the white has no mass. It's exactly what they say at Fermi. I agree with 100%. And it is all the burn. And the black is all the mass and no burn. And out it goes. And then it'll start to come back, because there's a void out here. And everything will turn around and start to come back. I just had a revelation. You see how these are the Fermi Lab point particles? They're showing the red and the black, and I'm showing the red and the black down here. And they're very easy to see. The red and the black has very little energy, so you can look at it easily. Well, when I say easily, doing what Rod did, you can see it. And you can see it. You see the neutrinos? These are the neutrinos. They're not quite fully formed photons yet, and they go from this state to sideways up like this instead of this way, and then they flip into the photon, and this is straight down the line to the Venturi. That's why they're interacting, turning into photons quicker. These are not. They're getting into this mess where they're going to concuss very shortly, and these are different photon and neutrino energies. And they say they change flavors, and yes, they do. And the photon is the fully formed particle. And again, they see all these crazy little particles, little bits and pieces here and there, 3 of them and 2 of them, and 1 and big ones and little ones and big glowy ones and less glowy ones, but they all come from the 2 particles, which is the black and the white. And they can come apart. There's no question whatsoever. This here and here this is what their normal, photon configuration is. That's normal. But once it hits that Venturi, all bets are off. All right, the black can't get through. So the black bounces back out. You see the black is laying on top of the white. That's the only reason we can see it. Dark energy is always behind the white. It's never on top of the white. The only reason it's on top of the white, it can't get through. So the white comes away all by itself. And here's where we should be able to get some energy. Right there is nothing but white energy. And there's no mass to it. It's just like dribbles down as energy, just as I showed you how it hit the house and just burnt the house up. So we're taking all that mass and keeping it out of the way and letting the energy come dribbling down inside into our photodiode. And really, that's all it is. It would be a photodiode. A big heavy-duty thing, because all you can have is electricity. And that is just pure, raw electricity. And that's what you put in your car. And because it has no weight, that has no weight to it. There's virtually no weight whatsoever. You saw it didn't move the house, but it had a lot of burn, and that's what makes your car run. It makes batteries fill up. When you fill up a battery, it doesn't take on much weight at all. It does take on some weight. Batteries, when they charge up, they get a little heavier because you're pumping in this, but this almost weighs nothing. The black is the stuff that weighs everything. You keep your solar collector right there. All right, let me show you something. Oh, before I do this, let me see it. See this here? This is the green. Now, the green is much more energetic than the red. This is unusual to catch them in such a perfect photon phase. This one's getting charged up, ready to spin. You see it getting all puffed up? And because it's still at the bottom, and this is still at the bottom. The next hit, it'll be spun. And here's the other neutrinos and all this stuff. But it's much more powerful than the red. And the blue, you really can't even work with it. So we never even work with the blue. So I can see why Fermilab showed the red one. Because they can't see the green or the blue as we can. The blue comes in so hot, you'd think it was one particle. But as it starts to slow down, and the light slows down, speeds up. That's all nonsense about light with one speed. All light together, when you turn into white light, yes. Let's say it does all have one speed, but that's all the most intense light there is. Will go that one speed, and all these other colors will go along with it. Now we're separating out the colors. That blue is very, very fast, and here it comes in as almost like one particle. But you can see as it spins, it turns by here. It's into the two. You can see there's two glowy bits, but you can't work with this. And CERN apparently can't work with anything because all they're showing was the black and the red. Now we can show the black and the red. We can show the black and the green. We show the black and the blue. But you can't really, the black and the blue, forget about it. The black and the green, yeah, we can see that. That's not bad. All right. But it's much, much faster. And we have them going through the same slot at the same time. You can see the green much, much faster and much more energetic. And of course the red is the slow one. We can just watch that just progress right across. And see the white is in the black here, in the bottom, that's top spin. You know, the white is at the top. That's bottom spin where the white is at the bottom. Same particle. Because when you take one click, it's the whole 9 yards at once. These things are going pretty fast. It's light. It's the speed of light. I don't know if I showed you this or not, but we're using electron showers. They're using proton-proton collisions, creating hadrons, creating decayed hadrons, creating high-energy neutrinos, creating all these different flavors, which I talked about, and then getting down to where we are with the energy of neutrinos. We started here. We didn't have to do all that stuff, gigantic machines, and it comes out with 100 giga-electron volts up to a few trillion electron volts. That's huge. Okay, let me bring you right through the whole process here. That's the pulsed red laser. This is exactly where it starts to accelerate. There's a Venturi down here. And this is just as it starts to accelerate, heading for the Venturi. All of these little white particles in the air are gases and heat electrons and particles that have one of those little white particles attached to it. And everything there is made of the same stuff. So this field has to push this field out of the way. These glow, this glows more because it's pushing harder. I call it push to shove. They shove back and they more or less get out of the way. And the pusher usually pushes his way through. And that's what's going to happen here. And now we're going to hit the acceleration phase. All right, so that was that wave. And now, pew, that particle which I showed you, the black and white particle here, is just rocket shipping out of here. Now, you see how it's starting? You can see it here. You can see it a little bit, not huge. But here it's starting to get glowier and glowier. And here it gets real glowy. And here it just gets, and here it explodes. Well, these are the neutrino phases. And it changes its mass and its energy because it's pushing back harder against its own particles that are ahead of it. Because they're concussing, pushing back. So that increases your neutrino value. That's why they say it changes flavors. This is acceleration of that particle. And that particle is this particle. And here it is in its acceleration phase, starting to be able to be seen. Before you can't see it. See up here, you can't see anything. Hold on. All right, you see up here? It's the same picture. Same picture. There's light coming through here, guaranteed, because here it is right now. And it's starting to be seen because it's stacking up on itself. It's becoming a neutrino. Back here, you never see that. It just be unknown. Here, it's right in the dead center of hitting the Venturi. So it's got, that's why we see it glowing and turning into the neutrino flavors, and then the photon, and then the muon and electron showers. All right, now the green does the same thing. I have the green doing the same thing. It's not quite so easy to see, but here they're both going through the Venturi at the same time. Now, I don't have the equipment to tell whether the green is actually faster than the red. So in other words, the red only comes out to here, whether it just concusses and it doesn't have enough energy to move and be so, brilliant. And the green has much more energy. There's no question it has a lot more energy. Is it faster? Maybe. I don't know. Can they test if the red is hitting the target earlier than the green, or later than the green? Is it slower? Is it faster? I don't know. But I can tell you one thing, this has a ton more energy. See how glowy it is compared to that, how dim? Same particle. That's that particle right here. All right, this is a different phone. Rod used the Samsung Galaxy S3, and he had just some fabulous luck. And again, he used the selfie side. Now, I didn't do a whole lot of this. I didn't need to. Rod just kept doing it over and over and over, day by day by day. And I can't thank him enough, because nobody would do this. And he didn't realize what he did, and nobody else realized what he did, and nobody would give me the time of day. And he stuck with me, and I've all sort of lost track with him. But anyway, I'm going to just keep going here. Now, again, here's the particles. These are the neutrinos. All right, they're called Dirac neutrinos when they're attached together, and when they're flopping and flipping, then they're Majorna neutrinos. And here they are right here. See, these are they're showing them side by side. They're really this way. They're always going to be polar. They're going to be going down towards the Earth, and when one of them's holding on the other one, when one of them's charging up, when it discharges or when it overloads, it flips, and then you got a dark side facing down, the dark side facing up. It's just up or down spin. It doesn't go sideways. Now, the Majornas are when they're in the flipping phase, and they're really they're neutrinos, basically. These are the neutrinos. They're not really into their full Dirac form. They're, as I showed you, the neutrinos. All right? Like these are neutrinos. All right, and then they start to fully form. And the same thing happens to the red. It's not just, and the same thing happens to the blue, only the blue you really can't see. See, the red comes through, it starts like this, and then it flips to the other neutrinos, and then it shows the photon phase, and here, just before it slams the wall, it's being concussed backwards so much that this whole region is just that's just stunningly glowing, and you can see it at the Venturi. Oh, see what happened here? The black says, I can't get through. Squirt that white, and it just keeps slapping it like spanking it right through there. Pow, 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 pow. And it comes through there. It didn't come through an atomic bomb. It's much more explosive than this, and it didn't move anything. It was just dribbling over there, burning anything. So all we got to do is just let it dribble into our solar collector. And now with these new perovskites and all these new different transition metal complexes, they can collect all these different frequencies, because you're going to have all kind of different frequencies. Once you hit white, you got a lot of different frequencies in there, and you got to be able to get them all. Otherwise, you can only pick and choose one or here or there. But transition metals and the exotic metals have a lot of capability of absorbing all different frequencies of light, because every one of these represents different frequencies of energy. That's why they all bond differently, and they bond to other things magnetically. So there's different frequencies of energy are going to bounce off them or be absorbed by them. All right, the color you see is what's bounced back, but there's going to be something absorbed. And they all absorb different frequencies. So all you need to do is like a paintbrush, spray paint. spray some of this, and 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 this. And when the light hits it, it will penetrate through those different layers and be absorbed by the ones that will want to absorb the electrons. And then they just go right down straight through, as I said, down into that collector. And if we could do that, I mean, this is walking around stuff. This is stuff you could do just like this. You see that? You can put something like this. Have any kind of outlet you want. Because all you got to do is have a regulator in there. So it can be 50 cycles, 60 cycles, 120, 220, whatever. AC, DC. And make it watertight, and it's all solid state. You carry that around anywhere you want. All these disasters that are happening. Plus, it's a green energy. We're not creating any excess expansion. All we're doing is taking the white away from the black. That's all. That's all. And that's all we want. But in order to get this to happen with generators and so forth, you got to force magnetic fields against other magnetic fields really, really, really hard. We don't have to do that. We just shine the light through the Venturi. Let the dark particles do the hammering for us. That's all. I'm telling you right now, I don't see this, and this could be done literally within weeks if it works. If it doesn't work, well, it's over. But it doesn't cost hundreds of billions of dollars to test it. All right, so I'm going to leave it at that. But if we could have this looked at least looked at, I think I've shown a very, very, very compelling case for this energy. And the glowing white particle. That is never like that until it gets pushed. And the only way it gets pushed is because of the Venturi. And the Venturi is an accelerator. So we created a desktop subatomic accelerator. And that's fission right there, and that's fusion. And that there is no question about it. And here's what they say right here. It started with the muon and the electron neutrino, the black and the white. The black ball just goes by itself, the muon, because it's a hard fixed particle. The white, precisely what you see right here. So what did we create? Electron showers? Yes, we did. And what did we create? Fission? Yes, we did. And what did we create over here? Fusion? Yes, we did. And what is this? It's raw, focusable, continuous electricity. It's just nothing more than electricity. All right, and then you put a solar collector there. I don't see any reason we can't collect that. I mean, if you do, I'd like to know why. I'm going to leave it at this. They know that the electrons create showers. When they come through, they're low energy. When after they concuss with a whole bunch of other particles, they keep cascading and creating high energy. And there's going to be a point when they reconcuss. Somehow there's extra muons laying around, and they start to grab back into those, and at that point they become back to particles. But here it's raw electricity. These are base track electrons. These are electrons. All right, these are muons, the black ones. They don't go through. They bounce back. Now, this isn't my work. This was done by, I can't remember who did this, so I won't say. But they're looking into this. They understand, because they're looking for these electron showers. All right? They can make these enormous amounts of energy. But they want to use these gigantic colliders to do this, and it's not necessary. You can do this in that little handheld device I showed you. Something like this should power a car, a house, farm equipment, anything you want. I'm telling you, right inside there, if this is the raw electricity, I think it is, it's just unlimited. And it's focusable, it's continuous, and it doesn't create any harmful gases. There shouldn't be any kind of, we're working with light, so we're working at the same thing, the light coming from the sun. All right, if you put your eyeball right there, that's not going to be good, but you're probably not going to do that. So I can't see this having any downside. And there's nothing but absolutely enormous upside if it works, and only take a month or so. MIT, Harvard, Yale, they should jump on this. They won't even talk to me. Fermilab absolutely refuses. He said, don't ever contact us again. I said, I found your particles. I found your exact particles. And he said, you're a nutcase. I mean, he did. He called me a tinfoil hat guy. I'm not kidding you. from Fermilab. He said, "Oh, you're a tinfoil hat guy." I said, "I got your particles, my friend." And then it went really downhill from there. I can tell you, it became a little bit on the nasty side. So anyway, and I've had this nothing but the same story. The only one that was nice to me is when I went to the University of Geneva for particle physics, and I showed them all this stuff. And I said, "You guys aren't even focusing. You're concerned. They're just coming hoping something's going to hit." I said, "You got to focus first of all, and then you got to use CMOS. You're having the observer effect, means that you're sampling some of the energy, which changes everything changes." I'm telling you right now, this was back in, I think, 2016, 2017, because I presented them all this. I said, "This is it." And they weren't nasty, they were nice. And they said they would follow me on Facebook or wherever. And I was kind of surprised they didn't want to go any deeper, but at least they did. They were nice. And then not even a year later, they shut down CERN. And they put in focusing magnets and CMOS detectors. I'm not kidding you. I am not kidding you. Now, whether I had anything to do with that, I don't know. It took them 3 years to upgrade for these focusing magnets so that the beams would come together instead of just passing by hoping something would hit. They have to really... And the coming head on is not the way. It is not the way. A Venturi forces the fields to crush sideways. This crushes sideways. It's much, much, much better because we can direct this, we can squirt this all day long into a substrate. Now, I'm going to leave it at that, but it's very, very distressing that the people that should be paying attention to this won't even allow me to speak in this realm. And I've tried literally everybody. I've got a pretty loud mouth, but it just doesn't seem to be heard. I don't know. So anyway, see if you can do something. See if you can talk to some physics people. Talk to somebody in the government. I can't get through to anybody in the government. And Fermilab is a government agency. They say, hey, give us your questions. Give us your questions. Well, ask them why they won't look at my stuff. All you got to do is go to Fermilab.com or whatever it is, and you'll see. Ask us anything. Well, I did, and they said, don't ever contact us again. So that's the kind of stuff we're up against here, is with the authoritarian, academic way of thinking. We're in control. You just shut up and do what you're told, and then you can get by. And that's what's happened to these poor kids. And I just did a couple of videos I did at least one on, this debt relief. These kids are sleeping in their cars. I'm getting stories from people that just are horrifying. And now they know they've been hoodwinked, basically. If they won't pay attention to what's put in front of them, like my Mudfossil research, this research, the light research, all that stuff, this changes everything there is. It changes history, it changes atomic physics, it changes energy, it changes geography, geology, anthropology, our ancient history. It leads somewhere into the religious realm, mythology, whatever you want to call it. As far as I'm concerned, a lot of that stuff was factual, and I show the evidence. I am a material scientist. Material. Material means I show evidence. Now, I may point to some ancient text that said this or that and say, can I prove that? And then I would, guess what? Virtually all of them, I can show evidence that they were pretty much on target. I know it sounds insane, and that's why I've been shuffled off into the woods. But honesty is the only thing that I care about now. I don't care about who cares what about me. I don't care about anything anymore. I just care about being honest, because that's exactly what will get you by. Because this world ends for everybody. Ain't nobody gets out alive. Kabish? We all come to an end, and it goes fast. So if you want to find another place, well, you better pay attention, because this was a place of learning. That's my estimation at this point. And I'm still in the learning phase, because you can never stop learning. There's nothing settled here, ever. All right, I love you all, and hopefully we can get out of this and get into a real educational system that's just true and honest. And it's going to displace a lot of people. Just a fact. All right, here's by the same guy, Don Lincoln. This is in 2021, and it's what is the smallest particle that exists. Now, Don Lincoln, senior scientist, Fermilab, which I have interacted with, and it has not gone well. He won't even look at my work, and I have absolutely verified the things that he said, but he has to understand the two particles that make up what he would consider to be an electron. Now, I don't know what this is all about, but he's talking about the smallest particle that they know of. The lowest non-zero mass particle we know of is the neutrino. Let me show you those, because this is right from his own same work.